right now. So we are going to talk about Sherlock, which is an automated anomaly detector built on Druid. So my name is Guru Ganesh, and my co-presenter is Jigar. And yeah, let's get started. So the motivation for why we wanted to talk about motivation for why we wanted to create an automated anomaly detector is basically like we had a reporting system at Yahoo, which is fairly standard. But it had like kind of similar problems that we see in a lot of different reporting systems. So for example, one thing that we saw is like the reporting system basically tracked several metrics, like, number of unique users, number of like sessions, number of clicks and all that. So that's all fairly standard. The thing that made this system a little unique is that at Yahoo, we have many different websites and many different like sub websites as well, right? So for example, Yahoo Finance, we have Yahoo Sports, Yahoo Finance, Yahoo News. On top of that, like we have Yahoo Finance UK, which may not be the same as Yahoo Finance US. So there are many different variations of each website. So we had a bunch of reporting dashboards for each of those things, and the things that we're trying to track is KPIs, but also like instrumentation bugs, right? So like if, for example, you have double the number of users on Yahoo Finance UK on one day, is that because of an because of there's genuinely like some viral Yahoo Finance video? So that's kind of like the reporting system that we had, and that's kind of what we were doing before. This was already cumbersome to begin with because we had to go, we had news, finance, sports, and on top of that, we had like UK, US, Canada, and all the different countries. But then on top of that, we also obviously grew in terms of data, right? And this is also common across the industry, right? There's always more data. There's never less data. One more problem that we had is that there are complex user engagement patterns, right? So for example, Yahoo Sports, there may be a lot of users during NFL season, but then after NFL season, there are less users, for example. Or for Yahoo Finance, if the market is closed on Labor Day, then you don't hear any, or you don't, like the traffic will be less on that day. So there's a lot of seasonality and a lot of like complicated engagement patterns. And so because of this, continuous monitoring is required. And we don't want to like manually we need to continuously monitor all of our websites across all metrics to make sure that product health is correct. So before we had like an automated anomaly service, we used passive monitoring, which was already getting quite cumbersome because we had a large number of dashboards. And also it did not scale to the cardinality of all dimensions. And we use threshold-based alerts, which doesn't take into, the biggest problem with that is it doesn't take seasonality into account, right? So you need to have a product manager who manually knows, oh, okay, it's the weekend, so Yahoo Finance, it's okay that there's less users. Or like, oh, it's NFL season, so it's okay that there are more users on Yahoo Sports or something like that. So with that all in mind, we created Sherlock. Well, we decided to create an automated anomaly detection service. Our data was already in Druid, even pre-Sherlock. So that Druid was like a natural choice for us to use in part of our system as well. Then EGADS is an automated anomaly detection service, which is built in Java, which is also built at Yahoo and later open source. So EGADS was used to learn seasonality and trends. And basically by putting these two technologies together, we were able to come up with Sherlock. So why we chose Druid? So we were already using Druid pre Sherlock, and it was a natural fit for us because it's very fast. It allows you to like quickly slice and dice data and do cubing and that kind of stuff. And we have time series data mainly, right? Because we want to see, like, our reporting systems are like, how many users do we have? How many clicks do we have? How many users do we have in a given day? How many clicks do we have in a given day? Things like that. How many views do we have? And Druid also scales to many different time granularities, and it scales to petabytes of data and many thousands of users. So let's talk a little bit about EGADS. EGADS is an open source Java library to automatically detect anomalies in large scale data. So there's two types of there's three different parts of EGADS. One is the time series modeling part. So the time series modeling part is basically like forecast, like given last week's data, forecast what's going to happen for next week. Then the anomaly detection module is basically like, okay, now given that forecast for next week, like, is it an anomaly or is it not an anomaly? And then the alerting module is, okay, if we determine that it is an anomaly, then we go ahead and report that. So putting all that together, we came up with Sherlock, which is basically like EGADS on top of Druid. You can think of it that way. And there are a couple of requirements that we had for Sherlock. One is that it should be relatively easy to use, relatively simple to use. Two is that it should be relatively lightweight. And three is that it should offer both like cron style anomaly job scheduling. So like, you can monitor jobs over a long time, or ad hoc anomaly detection as well. Yeah, so now I'll hand it off to Jigger, who will talk a little bit more about the deep dive into the architecture of Sherlock.
Sure. So in the following slides, I'm going to talk about the architecture as well as the job lifecycle in Sherlock, and how it processes the Druid query, and how it captures the anomaly, as well as the security underneath that we provide with this library. And yeah, so let's talk about the architecture. So as you can see, the architecture is very simple. So there is major three components. One is Druid cluster, and one is like a Sherlock library running on an instance, and Redis cluster. So the Sherlock library, it can run on any like a cloud infrastructure, a machine like a Kubernetes pod or Amazon EC2 instance, and you can horizontally scale them by adding more pods, and each instance can run separately as a monolithic web app. So this web app has it's written in Spark microservice framework. It has two components. One is a web UI, and one is a backend. It has embedded JD server, and the UI is written in HTML and jQuery, and it's very lightweight. So user can interact with this UI to schedule the anomaly jobs. And the backend is divided into multiple services. These services comprise of like a job scheduling service, a backup service, time series parsing service, and report generation service. And yeah, there are many services in the backend. So we decided to have Redis as a data store for all our job related metadata. So Redis, why we chose Redis is because most of our data is kind of metadata related to all the jobs and Druid clusters. So, and we need them in real time, very fast, and Redis can serve it very fast as a cache. So we chose Redis, and uh, all the job and Druid cluster related metadata we store and persist them in Redis. And there is a job scheduler as well. So it is implemented with priority queue logic. It has a job start time and frequency. Based on that, it schedule the job automatically within Redis, and our Sherlock server polls this priority queue periodically to look for any like uh, potential jobs to run at the current time. So this is the whole architecture. And next slide, please. So let's look at the job cycle, job life cycle. So users can go to Sherlock UI and create their jobs and launch these jobs. So these jobs are scheduled in Redis on the priority queue based on their start time and the frequency. So once the job is eligible to run, it pulls. So Sherlock pulls it from Redis, all the metadata from Redis, and it queries the underlying Druid query on Druid, and it collects all the responses. Once the response is collected, all time series parse. There is a time series parser which segregate all the time series from this response, and then it feeds all this time series to EGADS module. So this is a anomaly detection module, and um, it runs one by one each and every time series and spits out the anomalies. There is a a report generation service which basically generate the report for each and every time series, and it gives alerts if there is any anomaly to the emailer service, which can send out the email later. And it also stores all this report data in Redis for the later lookup on the UI. Uh, Next slide, please. So this is the sample Druid query for like an anomaly detection job. So in this query, you can see there is a matrix which is derived from two other matrix, M1 and M2, and there is some aggregation you specified, and there is a dimension field which shows you the group by dimension for this query. It's similar as a SQL group by clause. So there are two dimensions, D1 and D2. So once this query is input in the job by user, Sherlock uses this as a template every time it runs the job, and it modifies the query interval time during the job runtime, depending on what's the current time and what is the historical data at that point of time. Also, the granularity depends on the frequency of the job. Let's say if you are running daily job, then the granularity would be naturally daily, and in the case of hourly jobs, it's hourly. So Sherlock fetches all this information from the query to later use it in the downstream. Uh, Next slide, please. So this is the Druid response. This is a sample data point from a Druid response. So you can see at this particular timestamp, there are two data points. So why two? Because let's say D1 dimension has one cardinality value and D2 has two cardinality values. So if you combine all the combination, you get like two data points for this particular timestamp, and so it results in two time series. Later on, Sherlock input all the time series from the response to EGADS. Let's see how EGADS works. Next slide, please. Yeah. Um, so EGADS has two modules. One is time series modeling, and other is anomaly detection module. So let's talk about time series modeling. So in the time series modeling module, it takes in the original data value of the historical data points, and it tries to forecast the time series using the original values, and it tries to learn the pattern. So you can see in the beginning, like it looks like it's a weekly trend. So in the weekend, there is a dip in the data. So in the beginning, the model is not able to gauge the difference at like a weekend versus the weekdays. But as it learns through the time, you can see that uh, it can gauge the difference between the weekdays and weekends. So at the end, there is anomaly on the weekday, and you can see there is a black bar shown. Also, these other time series, you can see those are the error matrix it uses to figure out uh, the error percentage and error rate. So all these matrix are used by the anomaly detection model later to uh, to spit out the anomaly. Let's look at the anomaly detection module. So it anomaly detection module has three different types of algorithms. So there are three different types of anomalies it can capture. So one is a point anomaly, one is change point detection anomaly, and other is a anomalous time series. So with the use of K sigma sensitivity model, it models the whole time series as a Gaussian curve, and it spits out a point anomaly if there is any. With the kernel based approach, you can have a sliding window on a time series where you can detect the change point in your time series pattern. So let's say if your time series is behaving normally for 1 month, and then there is a very gradual rise in the data, but the pattern remains same. In that case, you might want to detect the change point. Then you can use this kernel based approach. And let's say if you have a bunch of time series and you want to detect which time series is anomalous, you can use this density based models to detect the anomalous time series among group of time series. Next slide. So let's see what are the securities we provide underneath. So we provide the MTLS support for all the Druid related communication from Sherlock. And for cluster level access restriction, there is a access control list where you can put your broker host, and it only allows to connect to those broker hosts. And for web API security, we use anti-CSRF tokens. And for the passwords like Redis password or any other service related passwords, there is a custom secret provider plugin you can use. For SSL context as well, you can plug in your custom SSL context in order to enable the MTLS communication. You can go through the configuration on the GitHub. There is a good documentation for how you can use this plugins and yeah, configure your custom thing. Yeah. So let's talk about the metadata management and backup. So metadata management is basically admin control for the Sherlock web UI. So through this web control, you can start or stop or delete like multiple jobs from the UI. And also you can rebuild your Redis index if there is any issue with the index. Um, Also, you can see what are the jobs pending in the priority queue, and you can manage the email subscriber list and their uh, email sent out time as well. Uh, we also provide a backup thread in our service, which periodically runs and backup the Redis metadata as a JSON to a persistent store. And in case of any like a Redis failure, if you are not using a persistence Redis, then you can use this feature to back up your Redis if there is any failure. Or let's say if you want to migrate your Redis instance to other Redis cluster, also you can use this utility for backup. Next, so the let's talk about the advantage of using the Sherlock. So initially we talked about what are the challenges we were facing. So after using Sherlock, we were able to periodically monitor our data using like automated job scheduling. Using EGADS anomaly detection, we were able to bring the false positive numbers to very low, since it uses the dynamic thresholding on the data. So it can learn the changing patterns and seasonality through time series as well, time series modeling algorithm as well. And using Druid faster aggregation and EGATS lightweight models, we can detect the anomaly almost in real time, because this models are really lightweight. You can learn them online. Next slide. So for onboarding and contribution, you can go through our GitHub, Sherlock or EGADS if you want to contribute. And to set up a Sherlock instance, you just need to uh, have it run locally, and you can run this Redis locally as well, or in a cluster mode as a remote as well. And you just need a Druid cluster with data to detect the anomalies. Yeah. Let's look at the demo in the next slide. Yeah.
Yeah. Okay. So I will just go through a quick demo here. So, um, First of all. Okay, so this is Sherlock. So you can see here we have several different functionalities. The first functionality is flash query. This is what we had discussed earlier about how you can have like an ad hoc anomaly detection query. Second, you can have a job, like a regularly scheduled job that can run, and you can get alerts like if an anomaly happens. You can add a new Druid cluster. You can add one Sherlock instance can connect to any number of Druid clusters, and then there's also some metadata management. So let's go through this one by one. So the flash query, so the way that works is first you select which Druid cluster you want. So we're going to select demo cluster. Then you got to copy the Druid query. You got to have your Druid query and then copy that in. The query time end is going to be today. Granularity for us is going to be 1 day, but you could choose minute, hour, or week, or whatever. And then the number of lookbacks, we're going to have 90-day lookback. Time series model, this is what we were talking about earlier. This is what's going to be used to forecast what the predicted value should be. And then anomaly detection module, this is going to be used to forecast, to basically say, okay, between the forecast and the actual value, forecast value and actual value, was there an anomaly? Case sigma sensitivity, if you lower this value, then you'll get more alerts. If you raise the value, then you'll get less alerts. So let's look at the results. So you can see here that that there are some results where you can see there's at first the model is learning, right? So at first, like these are alerts here because the model is still like kind of learning the data and it hasn't figured out the seasonality quite yet. But once it figures out the seasonality, then you can basically see that all of the then there are no more alerts on the weekends. You can see that there is one real alert here, for example, where the predicted value was much higher than the actual value. So that was a real alert. And then now let's go back and let's see if we increase the case sigma sensitivity to like, let's say 6, and we repaste the Druid query. No, and then we need to okay, fine, let's go with 28. And you can see that now we have no anomalies whatsoever, even though you can see here that there's a large difference between the predicted and the actual. There's no anomalies because the case sigma sensitivity is so high that you cannot, that it's basically like no longer significant enough. And you can also see that you can have multiple time series in the same graph, right? So here, for example, we have different time series. Like these are like different in our, like we have basically like fake data here for different countries. So you can just select like, for example, Great Britain or something. And you can see, again, because the case sigma sensitivity is so high, this is not an anomaly, but like normally this would be an anomaly. But this is as it learns, and then once it learns the seasonality, then it all smooths out. Okay, I also created a job beforehand. Let's take a look at, okay, so first of all, let's take a look at like if you want to add a new job, okay, you add your job name, right? So you can say like demo job, and then you add a description, and then you add an owner, and then you add an email. And then you select which Druid cluster to query for that job, and you put a time SLA, and then you put a Druid query in. So we'll just use our whoops. We'll use the same Druid query as before. And then you can put in the granularity, which is defaults to 1 day, but you can use whatever, minute, hour, day, whatever. And then you enter the number of days to train for lookback, the job frequency, and time series model, and anomaly detection model. So I already created a job beforehand, so we'll just look at that job. So for this job, you can see here that if there's, this job was started on August 4th. So before August 4th, we have no data. August 4th to October 27th, there were no anomalies. On October 28th, there was an anomaly, and then after that, there were no anomalies. So you can see like no job scheduled, no anomaly, error, or no data for time series. So if you look at the anomaly here, we can actually just see that it gives us some information, right? Like this was the country, this was the group by, this is the metric, this is the metric deviation, and this is the model information. So that's how, and so like on this day, October 28th, it would have sent an alert to whatever the email that we had put in at that time. So let's also look at adding a new cluster. You can add a new cluster. You can add any number of Druid clusters that you want here. You can enable MTLS. You put in the broker host, the broker port, and then the time SLA, and then you can save that. And also real quick, the metadata manager. So for example, in the admin, this is basically like an admin console. And here what you can do is you can like select multiple jobs to backfill. You can start or stop jobs. You can clear reports. And so this is basically like a quick little like admin console that you can use. And so that's all we have. Yeah, so if you have any questions, please let us know. And also, if you, again, Sherlock is open source and EGADS is also open source. So if you have any issues or questions, you can also just raise an issue on our GitHub page, which I can also just show you that right now. So this is our GitHub page. We have like a lot of documentation here. And yeah, if you have any questions, then feel free to raise an issue there as well. Yeah, any questions? I see there's some questions here. Okay, so would you extend Sherlock to provide other notifications such as Slack or URL endpoint? So internally, we do use Slack, but you can actually configure Slack to be an email. So there's basically like you can have each Slack channel individually has an email associated with it. So if you get that email, then you can send notifications in Slack, which is actually what we do internally. Then there's another question. Do you use Druid SQL queries? We do not right now, but this is actually a great, this would definitely be a great addition. Yeah, that's something to consider for the future for sure. Is there a learning infrastructure in place or does the algorithm learn while execution using past data points? Jigar, you want to answer this one?
I'm sorry. Can you repeat the question?
The question is there a learning infrastructure in place or does the algorithm learn while execution using past data points?
Yeah, it learns online, so there is no offline learning. Generally, we query the whole historical data in real time, and it would learn the pattern online for any job that runs. Yeah.
There's one more question. How do you manage cardinality explosion along dimensions like D1 10 values, D2 10 values, 100 lines per time point?
Right now, I think it can handle as many time series you can put. Right, we don't see any because it's horizontally scalable. You can have any time series you want as long as you have enough compute power. Yeah.
And yeah, as we showed in our demo, like you saw in the group by, there was like significant amount of cardinality, right? There was probably like, I don't know, at least 50, 100 values in there, at least 50 values in there. I'm not sure exactly off
Yeah.
the top of my
So
head, but that was fine.
yeah, if there is an issue, you can do like a filtering on top of group by, and then create like a separate jobs uh, for like let's say a slice of data and other slice of data. So you can separate out them as a jobs, different jobs. Yeah.
Right. So basically, in our testing, we haven't run into issues with cardinality. Oh, there's also one more question. Learning is also horizontally scaled. Vigor, you want to address that one as well?
Yeah. If you have like a more compute and the instances, it's distributed among all the instances. So yeah, it's a horizontally scalable. Yeah.
For the learning part, is it possible to tag an anomaly as a false positive to increase accuracy?
Right now, we don't have a
No.
feedback loop. Yeah, it's a really good point. Yeah.
When you say compute power, are you talking about the compute power of Druid or the compute power of or Sherlock has compute power on its own?
Sherlock compute power. Yeah, the instance where Sherlock app is running. Yeah.
Right. The EGADS, all the
Yeah.
on that, all EGADS is run within the Sherlock app itself.
Yeah.
So yeah, the Druid is used for querying basically.
Yeah.
And that's it. Okay. Yeah. Any other questions? Okay, great. Yeah, I think that's it for now. Sorry, really apologize for starting the session late. And yeah, again, everything here is open source. So if you have any questions or any comments or any, like if you want to contribute, then yeah, feel free to just take a look at github.com/yahoo/Sherlock. And yeah, we can continue the discussion there.